What's up, everyone? This is LeetCode 190, reverse bits. We've done this problem in Python, but now we're going to do it in C++. So yeah, we just have to reverse the bits of a given 32 bits unsigned integer. Pretty simple problem statement, right? I mean, you can just look at the examples, right? We're given an unsigned 32-bit integer, and we have to just reverse it. Now, in terms of how you approach this is a little bit of the tricky part, obviously. The problem statement is simple, but the actual approach is a little bit tricky. So we're going to use an example using 4 bits, right? So the way we're going to handle this is we're basically going to process every least significant bit for the input. And at every iteration, we're basically building out the reverse bit and storing that in a variable called answer, okay? So the way we get the least significant bit, obviously, is we're going to AND it by 1, right? So this is the example. Right, our input is this. So we AND this by 1, and we get 1, okay? So let's basically store that in answer. And we need to build this out, right? So the way we're going to do this is we need to handle all these bits, right? But since we're going in reversed order, we're going right to left. In answer, though, we're going left to right. Obviously, right? Because they should be reversed. So every iteration for our input, we want to right shift by 1. And for our answer here, we want to left shift by 1 because we want to keep appending to the end, right? So after every iteration, we're going to right shift by 1 to move on to the next bit for our input. So let's do it again, right? AND it by 1, we get 1. This, obviously, it's kind of hard to show in a comment, but I assume we already left shifted by 1, so we can append to the end here. We would append the bit we just got, which would be 1. Okay, let's right shift this by 1 again. 0 and 1 gives us 0. Assume we left shifted already by 1 on the answer, so we can append to the end here. Be 0. Right shift by 1. 1 and 1 gives us 1. Assume we already left shifted by 1 here, so we can append to the end. Append this 1. Right shift by 1, but again, now we have our input is 0 now. So we have no other numbers to go through, so we can terminate our loop. And this is our answer. Okay, so here's our input 1, 0, 1, 1. And the reverse should be 1, 1, 0, 1, which is what we have. So you see where we reverse this input properly, right? We reverse the bits of the given 32 bits unsigned integer properly. Okay, now this is an example, obviously, but how do we do this in code? Well, we know this input is 32 bits, right? So let's write a loop that goes 32 times, right? Okay. Additionally, let's create our variable answer and set that to 0 initially. Okay. So again, every iteration we want to make space for answer. So we want to left shift by 1. Now let's get the bit. Remember how we get the bit? We take n and AND it by 1, right? That's how we get bit. And the way we store that in answer is we take answer and we OR it by the bit, right? Because I guess I can go back to the example, right? We AND this by 1 and we get 1, right? This is the bit. And if answer initially is 0, and we want to basically just replace the least significant bit answer with bit. So, for example, if we have 0, sorry, not AND, we want to OR it. So basically, if answer is 0, which it always will be, right? Because we're always left shifting by 1. So we're always doing 0 and whatever bit is. If bit is 0, our answer is just going to be 0. If bit is 1, then answer is going to be 1, which makes sense, right? Because basically we want this bit to be appended to the end. So that's why we're using OR, the OR operation. Again, answer is always going to be 0 for the least significant bit because we're always left shifting by 1 at the start of every iteration. Okay. And remember, our input, we have to shift it by 1 to the right, bit shift it. So we would do n is equal to n right shift by 1. Okay. Now, at the end of this, we can return the answer, which should be the reversed bits. Okay. Now technically, if we want, we can make this a little simpler. Like, instead of storing this in a variable called bit, we can just put this in here, right? Okay, something like that. Again, just like simplifying, making our solution a little bit more concise. But yeah, that's a trick with this problem. It's really not that hard, conceptually, like to understand what's going on, but coming up with the answer the first time around is a little bit tricky. But anyways, I hope this helped. And yeah, I hope you understood my explanation. But I think this problem is pretty simple in terms of what we're doing. You just need to understand your binary operations. And if you don't, that makes this problem a little harder. So just make sure you understand your binary operations. Anyways, I hope this helped, and I'll see you in the next one.